I should have that song in the background. Anyways, so we know that the length of the pregnancy of a pygmy hippo is normally distributed with a mean of 200 days, standard deviation of 3.5. So I just provide you this curve for reference purposes, right? Use technology, make sure you understand that, use technology to answer the following questions. What proportion, another word yet, so remember this, probability, proportion, percentage, all the same. You could even say area at times. What percentage of hippo pregnancy lasts more than 204 days? So what am I using, normal CDF or inverse norm? Normal CDF because it's percentages. Okay? So I want you to just have this. And you know it's 204 days and more, right? Because it says more than this. So this is your start and your stop. You don't really have a stop, right? So you just put 1 million. And then your mean is 200. Your standard deviation is 3.5. If you do that, you get 0.1265, and that keeps going. If you multiply that by 100, you get 12.65% of pregnancies will last longer than 204 days. Okay? And remember, this is your mean, this is 200. This would be 203.5 technically, right? If you go up by a standard deviation of 3.4. So we want everything from here on, right? So technically it's asking for this tail right here. That's what we just found. Okay. Next, only 10% of hippo pregnancies last less than this many days. If I give you the percentage, you want to be using inverse norm. And guess what? If you have inverse norm, you already know your mean and you know your standard deviation. You just have to come up with this here. 10% of pregnancies last less than this. So you're probably somewhere here where this is 10%. So we're trying to figure out this x value here, like the number of days. So this is 0.1. A couple of hints here. It's only worth 1 mark. Usually, you don't need to subtract that percentage from 100. So if you plug this in, a second virus, right, and so forth, sorry, that's 195.51 days. Okay. Only 20% of hippo pregnancies last longer than this many days. 20% of hippo pregnancies last longer. If you put it here, it wouldn't make sense. If you put the line kind of here to find that value, this is way more than 20%, right? 50 is here. This would be 50 and 50. So in this case, it's kind of indicating that this is the line that cuts. The 20 goes on this side, because 20% of pregnancies would last longer than this value, right? Which means that the left of it is 80. 80, this is, so that gets you 1 mark. And I have to use inverse norm. 0.8, 200, 3.5. And that gives you 202.95 days. Here's the good news for you. If you used inverse norm and you put 0.2 in here, you still get 1 out of 2 marks because you're using inverse norm correctly. It's just that you haven't figured out that it should be 80% that goes in there. So 1 out of 2 if you used inverse norm. Okay, the middle 70% of hippo pregnancies last between this and this. Do this here. 70% goes in the middle, which means that there's 30 left over to split between the two tails. That gives me 15 here, 15 there, just making sure it all adds up to 100. So for this first, the x1, I'm going to do an inverse norm, and for x2, I'm going to do another inverse norm. For x1, it's inverse norm 0.15, that's correct. 200, 3.5. We'll figure that out in a bit. x2, another inverse norm. Right, this 15 and 70, that's 85.85. And that's also 200, 3.5. I get 196.37 days. Okay, and then for this one, I get 203.63 days. Okay, now listen carefully here. I'm going to give you 1 mark for using inverse norm. I'm going to give you 1 mark for having the 0.15 and another mark for having the 0.85. So this actually makes it, it's going to be out of 3. I feel like this is worth more than just 2 marks. Okay, so 1 mark for having the 0.15, 1 for the 0.85, and then you get a mark for using inverse norm in general. So if you used inverse norm and you used it twice, you would still get 1 out of 3 at the very least. So 1, 2, 3, 4, 5, 6, 7. So we've got 7 marks associated with this page right here. And let's go to the back here. Okay, so we've got the frogs here. The mean is 20 millimeters, standard deviation of 0.7. Calculate the z-score for a frog that measures 21 millimeters. So z would be 21 minus 20 divided by 0.7, and that amounts to, let's do this would be 1 over 0.7, and that is 1.43 is your z-score. That is worth a mark already. Okay, so what does that mean? That a frog with a length of 21 millimeters is 1.43 standard deviations above the mean. And this is just, you know what, you could have like a massive bullfrog, like the massive ones that are like a plate. And you could measure one and be like, oh, based on bullfrogs, this one is also 1.43 standard deviations above the mean. So it just kind of tells you within that category, are you above the mean or below the mean? How does it compare to the rest? Okay. B, a different poison dart frog is this many millimeters long. What percentage of frogs would we expect to be shorter? Okay, what percentage? You're using technology here. I didn't ask you to graph, right? So normal CDF, and this is kind of like your stop, because you want everything shorter. So let me see here if I can just quickly. This would be 20 millimeters. This would be 20.7 right here, right? If you add 1 standard deviation, 20.47 is somewhere in here. So we're essentially asking, what is that? What is the percentage that would have all frogs shorter than this length? So we go negative 1 million. And then 20.47, 20, 0.7. And that amounts to 0.749, which is, if you multiply that by 100, is 74.9% of frogs would be shorter than that. You good? Okay. What percentage of frogs are shorter than this or longer than that? Okay, so what's happening here? If this is 20, 20.1 would be somewhere in here. And 22 would be, this is 20.7, this is 21.4. So the other is right here, right? So we want this tail here, and we want all of that. So we're trying to figure out these two combined. I'll give you the shortcut here. I'll go normal CDF. I will find the in-between. I'll find this right here, the in-between. And if I do that, I get 0.4424. Sorry, it's all crooked and curvy. Okay, 0.4424. I found the percentage in between. I'm going to go 1 minus that. And so that would be 0.5576 times 100 would be 55.76%. And this is actually the highlighted portions here. If you use normal CDF for this part and this part separately and add it, that's just fine. So regardless, I'd give you 1 mark for finding the in-between and 1 mark for subtracting in this case. Fun stuff, eh? I know. If one would consider a population of 5,500 frogs, how many would be shorter than 20.1 or longer than 22.2? It's based on the previous answer. So I'll just go 0.5576 because I already figured it out, and multiply that by 5,500. And that gives me 3,066.8, which is approximately 3066 or 3067 frogs. A mark for that. This last one, I am very curious to see if you got that one. I'm going to make that a bonus because I didn't show you this yet. So that's going to be a +1 if you get this one right. But please pay attention. I'm going to use this as a lesson, okay? And then later on, we're going to go to our notes and also cover this part. This is like a, I don't know where to put this in my booklet scenario, so I'm going to just add that later on. Please pay attention here. A bumblebee dart frog with a length of 33.5 millimeters has a z-score of -1. That goes together. Where would a z-score of -1 put you? If this is 0, then this would be 1, 2, 3. This would be -1, -2, -3. I know the curve looks like it's touching the x-axis, but just disregard that for now. But if the z-score is -1, if this is -1 here, we can match that with a length of 33.5 millimeters. Okay? These are matched up here. A z-score of 2 has a length of 38. Sorry, what is this here? 1, 1. There we go, 2. This puts you at a length of 38. So we want to know what the standard deviation is of this set in terms of millimeters. Okay? The mean and the standard deviation. So here is the standard deviation is the first one you should do. I'll give you the formula. You go upper minus lower. I'll give you this one more in your notes, one more time, but and you might say, what? Upper minus lower divided by z-score of the upper minus z-score of the lower. That's how you find the standard deviation. So you go 38 minus 33.5 divided by z of the upper is 2, z of the lower is -1. that would give us 4.5 at the top. And what's 2 minus -1? The two negatives turned into a positive, right? So it's 2 plus 1, which is 3. So 1.5 millimeters is the standard deviation. What is my mean, folks, based on this information? How can I find my mean based on that? Could I just go 33.5 plus 1.5 and then get me to this? Right, remember, we always add a standard deviation if we go to the right, or we subtract if we go to the left. So it would be 33.5 plus 1.5. And so it would be 35. And if this was a little bit, don't worry about it. That's why I'm making it a bonus right now. We'll do it one more time in our notes. So this back side, let me just see here. 1, 2. This one is worth 2 marks. 3, 4, 5. So it's worth 5 marks. The backside, not including the bonus. So you got the bonus, you get 6 out of 5 on that. So 5 and 7, 12 total. Name and last name on there, okay? So, I'm going to come by and pick those up. And grab your booklets.